find the right slide. And let me take attendance. Absolutely hate when I have a sub because it takes me forever to seem to be able to get caught back up and take care of things. Now, if you were not here Friday, which, I mean, I could see who had accessed Canvas and who had not. So if you were here and you did not notice that there was an assignment in Canvas, there was. It was a rather easy crossword puzzle on the atmosphere, but y'all, that locks at 4 today. So if you weren't here, I mean, you've had access to it. I don't see anybody online yet. Michael, Jessica, yes, Jenna. Just a second, let me take attendance. You guys should know the answer, at least the first part. The first part to this opener. Not back there. Emily. Just gonna see if these people log on. All right, so last week, we were talking about air pressure and we sort of left off with humidity. And I think this was the class where I realized that I didn't get through the last slide from the previous class on condensation, that there's a few major types of condensation. We've got clouds, we've got fog, we've got dew, and then we've got frost if it's too cold. Somehow I didn't do that very last slide in first period, so it's rebuilt back into today's notes. We're just sort of continuing on where we left off. There's this thing right here that measures humidity. Not hydrometer, hygrometer, H-Y-G-R-O. I know hydro makes more sense, but that's not what it's called. And it's gone up a little bit. It's at 43% is what's measuring the relative humidity. So humidity is not exactly the same thing as relative humidity. What's the difference between the two? Yes.
Humidity is the percentage of humidity.
Right. So it's the air that we're breathing right now is basically 44% full, is essentially what that translates to. And the colder the temperature, the less moisture. So if we didn't change the amount of moisture in the air and we made it colder, that relative humidity would go up. If we made it warmer in here, which is what happens when the AC doesn't work, then that number would go down. Yes, I know technically the moisture is changing a little bit because even with these masks on, as we're breathing, just the moisture from our lungs is actually very slightly changing the percentage of the moisture in the air. Good for us. Air conditioners are really good about taking that humidity back out. And if you've never had like a window unit, they drip outside on purpose. They remove the moisture from the air in order to help decrease the temperature. You're ever in a situation, you have any kind of flooding like how I went through, you can't just run the AC unit. You need to bring in dehumidifiers because that AC unit, it'll overwork itself and it'll break because it's been spending too much of its time trying to reduce the amount of moisture and it's not actually cooling anything off. Hopefully you guys don't ever have to deal with this because they are not fun to deal with. Humidity and cloud formation. Did anybody need a paper copy from up here that did not pick one up? Because everything is in Canvas. You're going to have paper copies. Humidity is the amount of moisture that's in the air. Anybody else want a paper version of this? There are a couple different ways that you can get moisture into the air. The natural process is called evaporation. You could force it to go by boiling things. No, I don't think it really gets that cold here, but I grew up in the Northeast and we used to have this old school kerosene heater, which was awesome, just awesome at heating the basement, except for when you burn yourself on it, like I did multiple times. But it would dry the air out. And so what we used to do was put a pan of water on the top of the kerosene heater and it would put the moisture back into the air. I don't know if you've ever been around really, really, really cold, dry air, but you get nosebleeds like that. because the absence of moisture in the inside of your nose cracks. Just like when we have cold fronts and your lips get chapped. It's reduced moisture, and then it's trying to literally pull the moisture off of you to fill the air. I thought it felt awesome this morning.
It felt great yesterday. It was just nice and cool yesterday.
Mm-hmm. I'm not used to, I mean, we are in Texas. We basically have hot, and then we have not so hot.
Yeah.
I mean, you'll have a few days where it's cold, and yeah, you might get snow here and there, but it's basically really, really, really hot, and I can't breathe, and it's just, oh yeah, it's not so hot today. It feels great.
Yeah. For the past couple of years, we haven't got snow. But when I was little, we had snow.
Yeah, it's, I remember, because I'm from the area. My parents still live in the house that I went to high school in Keller. And this area gets a little bit more snow than like deep southeast Texas where I came from. Seems like we had to have a hurricane. Every time we had a hurricane, that following winter, we actually had snow. It happened with Harvey, it happened with Ike. I don't know what happened with Rita. I wasn't down there with Rita. That was 2005-ish. Well, and there's another hurricane headed for Louisiana, y'all. There's another one heading straight for it.
At that point, you're just going to calculate the entire and be like,
Well, I mean, Lake Charles was destroyed, and then that next one that came through wasn't anywhere near as bad, but it was more towards the eastern part of the state. Well, this one's projected to go right up the eastern part of the state too. When we do the Coriolis effect, you'll see when you look at the Earth, just like Jupiter's obvious because of all the clouds. There's like different bands, different colored bands, and they go opposite directions, just like on Earth. It's just we're not filled with the same type of gas. Ours is clear, so you can't see them. But you notice with the storms from Africa, they head west, and it seems like right around Louisiana, they go north, and they start going back east again. Because right at that area is the boundary of the winds that are trying to go west and then the winds that are trying to go east. It's what drives our weather. It's called the Coriolis effect. We will do that most likely in the 4 to 6 weeks when we come back and talk about this stuff all again, but in depth. And so I could give you example after example after example, but it all does the same thing. Yes. So if the air that we're breathing, let's say that approximately a third of the moisture that's possible is in the air, that translates to 33% relative humidity. If it's a fifth of what it can hold, then it's 20% relative humidity. If it's completely saturated and we feel like we need gills to breathe, then it's 100% relative humidity. Completely saturated does not necessarily mean rain. It means it's really likely it's going to rain. But what it has to do in order to force the rain to occur is it needs to cool off a little bit. Because as soon as you cross that threshold, then you reduce the amount of moisture that can be held in the air. It's got to go somewhere so it comes out, and it does so in some form of precipitation. And like I said, right now it's, according to this, about 43%. I'm assuming that that's accurate. I've had that thing for a very long time. My barometer's not in the best of shapes, but it says we're at 1,006 for the pressure. And I have seen these things. My parents had an old school one. I think they still do, actually, downstairs, where when the weather was changing, when we had fronts come through, you could watch that needle move. And if we had a front coming through, normally the needle fell. Because this area is notorious for its storms. Looking like a good anvil cloud full of hail. Mess with the barometer. Let me double check online and see if everybody's come on, because I didn't see a single person on it. Yep, I see Isabel and I see Jace. You too. It looks like we are going to be having a test on Friday. When I was building this last weekend, I didn't want to put too much on one. I could have probably have done what we're doing this week in 2 days. I just didn't want you guys to be going all the way to the bill, and then not have time for the assignment, because I went through and I checked grades in Canvas, and I'm noticing there are some people that haven't done a dang thing. Even though you've been here, there's nothing that's completed, and I kept telling you that, let's see in here. I did almost every day last week. These are the people who did not turn stuff in. Well, that one never signs on, so that's that case. But I had a lot of you that did not do that cross proposal that was left. The ones I did get was Tyler, Jenna's not here, Jaron, Huey, Hero, Jace, who's online, I got yours, Parker, Ava, and Hernan. I did get yours. I got the submission, but the rest of you, for whatever reason, you have until 4 o'clock, and that is it. Is anybody still? No, she's still there. Oh, it's frozen. Are we ready? Yes? Okay. Right, so once again, what saturated means is it can't hold any more water. It's at its tipping point. It doesn't mean that it is raining. It means it wants to rain. Now, because if you're 100% saturated and then the temperature goes up, then it's not going to be 100% saturated anymore. That number goes down as air gets warmer. The reason why this happens, and I wish I would have thought before a piece of lattice from home, I didn't do it. So like around decks, especially on the bottom, you see what's called lattice. It's like a bunch of pieces of thin wood that they're stacked on top of each other, sort of like this. Okay, so the warmer the air, the more spread out those holes become. So the lattice itself is sort of like the water molecules. The holes in it would be the space between said water molecules is vapor. And as you heat up, those expand. And well, moisture, as far as your air is concerned, moisture wants to fill into those holes. And the more spread out it is, the more moisture can be held within said holes. That's also sort of the reason why ice floats. When ice freezes, it expands and it traps air in the same concept as that lattice, and that reduces the density, which means ice floats. If ice didn't float, our planet would be a giant ice ball. It would never thaw out. So hopefully you learned about the polarity of water molecules when you were in chemistry. I don't want to go back into chemistry with you guys. Cold air, and it's going to condense, it's going to shrink down. Those holes in between the particles of the air, the nitrogen and the oxygen and everything else that's up there, those holes get smaller, the water gets pushed out, which is why cold air cannot hold as much moisture as warm air. It's just more space. Okay. If your air is 100% saturated, then the relative humidity is 100%. If the temperature drops, the water has to go somewhere, and it forms some type of precipitation, normally rain. But it could be snow, it's cold enough. If it's deposition, it could be hail. But for our area, it's normally rain. And we have really nice cold and warm fronts coming together. We get all different kinds of wicked weather, thunder, lightning. This area has some of the most beautiful lightning storms. I've seen pink lightning here, I've seen green lightning here, some purple lightning here. That has to do with the chemicals that are actually in the air. And unfortunately, the more polluted certain areas are, the prettier the weather becomes as far as colors are concerned. And sunsets for that matter too. Like I said, I'm not encouraging you to go to like burn a tire in your backyard so that you have cooler weather, but the Dallas-Fort Worth area isn't exactly the cleanest of air. It's not as bad as the smog that's out in California, because that all gets trapped by the mountains. It can't go anywhere. Here, at least it can go somewhere. Which, I bet you, the storms in China are beautiful, because they're notoriously polluted. In fact, their pollution goes across the ocean into Japan. There's nothing that Japan can do about it. China just doesn't, they don't self-regulate the way that our country does. They don't have all the, like the EPA and all the other regulations that control how much the carbon footprint that we're putting out. Okay, so once again, 100% relative humidity means it can't hold anymore. It does not necessarily mean that it is raining, but it wants to rain. If somehow any more moisture is put into the air, it will precipitate out. Or if the temperature drops at all, it will precipitate out. Now, the faster the temperature drop, the stronger the storm essentially should become. And we'll get into all different kinds of, well, tomorrow we're not going to go into depth with clouds, but we will talk about the major categories of clouds. You've got your very high altitude, like what we've seen right now. We still have all that haze. I don't really see any clouds. And we'll talk about why clouds are white also tomorrow. I might get into it a little bit today. So the things that affect how much relative humidity, obviously the sheer amount of moisture that's in the air. The more moisture that's evaporating, the higher that percentage is going to become. Like I said, evaporation is the natural state that we put moisture in the air. You can boil it, you can force it to go, but normally water is not going to boil on the surface of a planet. It can get hot, but it shouldn't boil. It just doesn't get hot enough for that. And this is also a reason why it's more humid towards the coast. You've got the ocean right next to you. It's going to evaporate into the air. That's why the coast doesn't really heat up and cool down as drastically as the desert. I don't know if any of you have ever been to a desert, but it can be 100 degrees during the day and 20 degrees at night. Because there's no moisture in the air, or very little moisture in the air. Water has a very high ability to hold on to heat. Its specific heat is rather high. And if you have more moisture in the air, you have less of a noticeable flux in temperature between night and day. If you have less, like in the desert, then you have a much more noticeable difference between night and day. And it can be like 50+ degree temperature swings easily. So the other thing is the temperature in the air. The colder it is, in general, the higher the relative humidity becomes. The warmer it is, in general, the lower the relative humidity becomes. I'm not going to make you do a combination of the two. We're going to specifically take a look at how to read a temperature chart to measure relative humidity, which is the first question that's on the Canvas assignment, so please don't try to do it. It's really not hard to read at all. We need to teach you how to do it. This is a fancy type of hygrometer. I know hydrometer seems to make more sense in your brain. It's just not what it's called. But hygrometers measure the amount of moisture that's in the air. That weird looking thing is two thermometers that are attached to each other on a cable, and it's called a psychrometer. You literally whip this thing around in a circle, and it's got two separate thermometers, one of which is a naked thermometer, and there's nothing on it. This is a normal old thermometer, this guy, one on the right. The other one has a wet cloth that's tied around the bulb of the thermometer, and when you whip this thing around in the air, that wet cloth allows for more evaporation, and that wet bulb is going to read a lower temperature than the dry bulb. The dry bulb is a naked bulb, regular old temperature. The wet bulb has a wet cloth wrapped around the bottom of it. It's going to read a lower temperature. And then knowing the dry bulb's temperature, the warmer one, and the difference between it and the wet bulb's temperature, where they crisscross on that chart, which I put in Canvas for you, you can figure out the relative humidity. If they're the same temperature, you're at 100%. Which is why that column isn't even on the chart that I gave you. But I've seen multiple versions of this guy that you guys have in Canvas. And the other one that I saw that I almost put on here, but it was too big of an image. The very first one had 0. That means that there's no temperature difference between the two bulbs, and it's 100% relative humidity all the way down. And if it cools off, or if more moisture goes in the air, it will rain, or some type of precipitation. I have no idea if we have any of those things on campus or not, because this stock room is aquatics and environmental. I don't know where they were storing all the earth stuff. I think it was upstairs. And I need to figure out a budget, because our box that we have back there are, the kits are missing things. They don't have keys. It would be nice to have an updated set for you guys. Especially since we're not supposed to be sharing things with touching it. I don't know how I'm gonna disinfect with rock. I guess I can spray with Lysol. I don't know, I haven't got that far into that. And so the first thing you're going to do is, I mean, if you literally had one, you're going to write down the temperature of the dry bulb. So dry bulb first, then you're going to read the wet bulb. You may have to actually take the clock off of it, depending on how far up that alcohol column has risen, because we don't use mercury anymore, because it's toxic. And then the difference between them, compared to the temperature of the dry bulb, where they intersect on that chart, that's the relative humidity. It's not really hard. You've just never read that chart before. RH is short for relative humidity. I do like to abbreviate like crazy. Once again, if your two temperatures are the same, if they're both 20 degrees, which is about what it is in here, give or take, it says it is 21 degrees Celsius in here. That room temperature. If they're both the same temperature, then your relative humidity is 100%. That is not on that chart. We're going to have plenty of time to do this assignment in class. Uh-oh, let me fix it. Tabs me out. No, go away. There we go. Let me fix it. I saw today that Fort Worth and Dallas schools were going back to in-person today. We have a lot more students than we do. Let's see. Still the same two people. All right, let me show you how to read this chart. It's not hard. So you guys have this, and it has all these instructions on the side. This is the one that should have been transported over onto Canvas for your first question. So if, let's just say that it's, well, let's say it's 20 degrees, which is just a little bit cooler than it is in here. Then my dry bulb will go down to 20 degrees, and I'm taking a look at this. I know you guys can't see online, but we're taking a look at this particular row if we're dealing with 20 degrees. And then let's say the dry bulb's 20, let's say that the wet bulb is, I don't know, 13. Then the difference between the two is 7 degrees. So then I would come over here to the 7, drop straight down, and if that's a true statement, then it's 44% relative humidity, which is actually ironically, sort of what it is in here right now. It's saying it's 43 according to that. You literally go down to the temperature on the dry bulb, and then you take it across to wherever the difference is between the dry and the wet bulb and where they intersect. That's your relative humidity. It's not a difficult chart to read. You just never read one of these before. So I got a couple of like example problems. So if the wet bulb is 14, then that's over here. Of course, it's the entire thing. And then if the difference, if my dry bulb is 14 and my wet bulb is 10, and the difference is 4, and where they intersect, the relative humidity in this case would be 60%. It's where they cross. It's really not difficult at all. If the dry bulb is 4, then that's this column. Okay, if the wet bulb is 3, then the difference between them is 1 degree, and that's 85% relative humidity. Dry bulb is 4, which is this one all the way across. I just stopped it here because I know that the wet was 3, but 4 minus 3 is 1, so there's 1 degree difference between the two, and where they intersect is 85%. This is like one of the first like actually applied things that ask you guys to do. It won't be. It won't be. It could be the same number, and because like I said, the one that I gave you, really there should be another column like this. If this, the other versions of this that I've seen is it was 0 but it was 100% relative humidity all the way down. I just didn't put that on here because I knew that this is going to be too small for you guys to read and more lines of stuff on this thing. Yes, they get, I think I animated this twice and I have no idea why. All right, condensation. This is sort of where we left off, and I know that I didn't put this on the first period, so I'm going over it anyways because there's some extra words. Condensation is when the water wants to go from the vapor state, the gaseous state, to the liquid state to make a water droplet of some type. The condensation occurs when you're saturated, which is 100%. When either more moisture is put in than what it wants to hold, or the temperature drops. Either situation, the water wants to come from the gaseous state, which is vapor, to the droplet state, which is normally rain. And the reason why clouds form up in the sky is because as the warm, moist air starts to rise, there is less pressure, and it starts to expand, there's less friction, it starts to cool off, and voila, you've got condensation on nuclei up in the air. If you've never noticed, fog happens at night. And then once you have enough time where the sun has been exposed to said fog, it burns off. Fog doesn't normally happen in the middle of the day. There are some exceptions if you're in a very, very cloudy area, such as like Seattle, especially since it's next to the gosh darn ocean. You're going to have foggier conditions later going on into the day than you would say here. Fog is just a cloud that hasn't been heated up yet. When they heat up, they're less dense, they stay in the sky. If they don't heat up, it means that the sun's not there to heat them up when they sink. Hence, fog. Like I said, we'll talk about the major categories of clouds, but we'll come back and do them in depth later this year. We talk about different types of tornadoes and weather patterns. Certain clouds are indicative of certain types of weather. Really, the only one that you guys probably are familiar with are ample clouds, because those are the ones that spark tornadoes. You need to know what they look like, because that happens here. They literally look like an old school Acme Coyote Roadrunner amber. They're just not black. So a lot of times they turn green, and that's not good. And please don't stand outside and watch the tornado go past you. That's not a wise decision. You see those storm chasers that chase after them, and I'm just like, gosh darn it, y'all. Every now and then you hear about, like, they get run over by the tornado and they get killed. You can't predict exactly where those things are going to go. I mean, You have a rough idea from pressures, because if there's a low pressure, it's gonna tend to go towards that. If it's a high pressure, it's gonna tend to go away from that. It's not like it's gonna broadcast where exactly it's going to go. All right, last little bit, and I think this is the last one. Dew point, we did talk about this last week too. No, I think there's one more after this.
No, it's like 3 other sections.
Well, they're between this one and the next one. The dew point this morning was at 56 degrees. When I walked my daughter to the bus, it was 55 degrees. If we would have walked through the grass, our shoes would have gotten wet. Because it was below the dew point. The dew point is the temperature at which you're going to have the water. In this case, it's going to condense down onto the blades of grass. Once again, cooling air, it is more dense, and it pushes the water literally out of it. It has to go somewhere. In this case, the dew is normally on the ground. I know when I was little, I didn't understand like any of this when I was little, but I was always curious, like, it didn't rain, how did the ground get wet? Well, it was because the temperature at night was below whatever that dew point was. I'm not mistaken, it was at 56 degrees this morning. I'm almost positive. Yes, the dew point was at 50. Well, now it says it's 57. But it was this morning, it was 56. That just literally changed in front of my face. And it says the pressure outside is 30.16. But that's with inches. That's not with millibars. The one that I have up here does it with millibars, and I don't remember the conversion factor to go in between the two. It says it's 85% humidity outside. Thank you, James Carrier, for inventing air conditioning. It would be horrible with 85% humidity in here. We got one more, and that's going to be the size of a raindrop. Raindrops are big. The little droplets that are in a cloud are smaller, and then the things that the condensation occurs on are even smaller yet. It's called condensation nuclei, which can be a bunch of different things. Just depends on what's present in the air. Right now, we got a heck of a lot of smoke particles that are present in the air. So more often than not, for our area, it's either going to be the smoke, which is ash, or pollen, although the pollen count is way down. That fronts, when cold fronts come through, like this one that just did, they push that pollen out. Because your cold air is more dense, and it literally pushes the particles away. Yes, some of them are left behind, but most of them get pushed out. So condensation nuclei could be pollen, could be dust, could be smoke, could be ash, could be all different kinds of pollutants. The air quality is actually pretty good right now. But like I said, the more city-like the area is, the more polluted the area is, just because there's more people there. And certain areas are a lot more polluted than others. I mentioned California. Now, all the pollution hits the mountains, and it can't climb them. It can't do uplifting all the way over the mountains, and it gets stuck. And if you ever fly into LAX, and you're going over, I gotta think here, Arizona is right before California, if I'm not mistaken. When you're going over the desert, and you go over the Rockies, it's like clear, 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 and then once you go over the mountains, it's nothing but smog. Because it's trapped, you can't go anywhere. So a regular raindrop is the biggest. They're about 2 millimeters in diameter, about that big. Your droplets in the clouds are quite a bit smaller. They're a hundredth of the size of an actual raindrop, 0.02 millimeters. Your nuclei are smaller yet. So you have your itty bitty teeny tiny little particles that are floating around in the air. It's the pollen and ash, really, smoke for us. Your little droplets are going to form on top of those. They're still teeny tiny. They're heated by the insulation from the sun. which makes them less dense than the air that's around them, is why clouds float. The heavier the cloud, the lower it's going to be. And the clouds that you guys think of are the ones that cause rain. They're called cumulonimbus clouds. We will talk about the major branches tomorrow. I just couldn't, I mean, I could have put it all together, but we would have gone straight to the bell. I'm trying to give you guys a chance to, let me freeze this, to take care of the assignment in class. There is an assignment that goes with this, and the very first thing it asks you to do is to read one of those charts. Let me stop this recording in just a second.